In today's class, we will see some problem based on Gaussian law, Gauss's law. The first one, if the radius of the Gaussian surface enclosing a charge is halved, if the radius of the Gaussian surface enclosing a charge is halved, how does the electric flux through the Gaussian surface change? If the radius of the Gaussian surface enclosing a charge is halved, how does the electric flux through the Gaussian surface change? So, by Gauss law, we know that the flux is given by Q by epsilon naught. By Gauss law, we have flux as Q by epsilon naught. So the flux depends upon the total charge and not the area of the Gaussian surface or the radius of the Gaussian surface. So the flux depends on the total charge enclosed in the Gaussian surface, not on the radius. So in this case, the total charge enclosed by the Gaussian surface remains the same. Even though you halve the radius, the total charge remains the same, and hence the total electric flux will remain constant. So we'll write the answer. Total charge enclosed by the Gaussian surface remains the same even when radius is halved. Therefore, total electric flux remains constant. Total electric flux remains constant. Total charge enclosed by the Gaussian surface remains the same even when radius is halved. Therefore, total electric flux remains constant. There will not be any change in the electric flux through the Gaussian surface. Hence, there will not be any change in the electric flux through the Gaussian surface. Let us see another problem. Second one. A point charge causes an electric flux 3 into 10 to the power minus 14. So 10 to the, sorry, sorry, I'll just erase this and I'll just type once again. A point charge causes a point charge causes an electric flux of 3 into 10 to the power minus 14 Newton meter square per coulomb. So here 10 to the power minus 14 and Newton meter square per coulomb. So this is meter square, Newton meter square per coulomb. A point charge causes an electric flux 3 into 10 to the power minus 14 Newton meter square per coulomb to pass through a spherical Gaussian surface. To pass through a spherical Gaussian surface. Calculate the value of the point charge. First one, calculate the value of the point charge. B. If the radius of the Gaussian surface is doubled, how much flux would pass through the surface? A point charge causes an electric flux 3 into 10 to the minus 14 Newton meter square per coulomb to pass through a spherical Gaussian surface. Calculate the value of the point charge. And the second question is, if the radius of the Gaussian surface is doubled, how much flux would pass through the surface? We'll solve this. So by Gauss law, total electric flux through the Gaussian surface is given by 5s. Total flux through Gaussian surface is given by 5 is q by epsilon naught, or charge enclosed q is 5 into epsilon naught. So 5 is 3 into, given 5 is 3 into 10 to the power minus 14 into, you know the value of epsilon naught, 8.85 into 10 to the power minus 12. Now calculate this. So 3 multiplied by 8.85 will give you 26.55. 10 to the power minus 14 minus 12 is 10 to the power minus 26. So this much coulomb. The unit of charge is coulomb. So charge enclosed by the surface is 26.55 into 10 to the power minus 6 coulomb. So this is the answer for question number A. You can write here A. And for B, before this we did one problem. So it is understood from that problem that if the radius was halved, the total charge remained the same, and hence the flux also same as before. So here also electric flux passing through the Gaussian surface depends upon only on the charge enclosed and is independent of its size. So if the Gaussian surface is doubled, the charge remains the same, and hence the flux also will remain the same. Answer for B. Electric flux passing through the surface remains unchanged. Because it depends only on the charge enclosed by the surface. And not on the size. Electric flux passing through the surface remains unchanged because it depends only on charge enclosed by the surface and is independent of its size. You can write and is independent of its size. This is the answer for A and B.